Good morning all, this is a Parkside cordless battery adapter. It's a sort of battery topper thing which slides onto the 20 volt Team series battery and gives you a little light and also a couple of USBs. So let's cut this open around here like so. Now I would imagine that this was being sold in Lidl at some point or other, but I wasn't into buying stuff from Lidl at the time, and particularly not the Parkside power tools, so I missed it. So I had to buy this off the guy who goes into Lidl, buys up a load of these things, and then when they're no longer available from Lidl, he sells them on eBay for twice the amount. And I was happy to pay it because I was desperate to get my hands on this thing because it just looked like fun. So let's put this on top of a 2 amp hour Parkside 20 volt battery. Oh, we've got a red light. Now, does that mean the... Probably not. Let's press that. We've now got a flashing red light. And we've now got a torch. Okay, so that probably turns the USBs on. Let's stick some lights in those and have a look. Right, a cool white and a warm white USB LED thingy. Brief flash, but that's because I just had it switched on. So they don't come on auto-magically. You have to press the button. That flashes a few times and then it puts the outputs on. And I would imagine they'd stay on. Otherwise it would be pretty stupid, wouldn't it? Let's take them out though and see how quickly it turns itself off. Oh, very quickly. Surprisingly quickly. So turn them on again and then turn the light on. So that's all pretty cool. But of course what we want to know is what is inside it. And it has screw holes, so I hope we can find out. Nothing fancy in here, just Phillips, but they are very, very tight. And that one I've already partially undone. Okay, let's see what's inside. Now I'm guessing a microcontroller because it's sort of on to turn the USBs on. Has a little bit of capacitor energy in there. And then a second press to turn the light on and it flashes. So it does some sort of fairly intelligent, clever stuff. Oh yes, there's a few bits and bobs on there. Okay. So what do we have on here? Well, we have a buck regulator. That's an AP2962 3 amp buck regulator. The diode for that and an inductor. There's a microcontroller there. It's a Holtec. Might get a bit closer in on that in a moment if I can. There's a little HT7550 5 volt regulator there, linear regulator. Not quite sure why that's there, as well as the 3 amp buck regulator. I mean, certainly we need a fairly beefy step down regulator to go down from the 18 volts on the battery connectors here to 5 volts. Now it says maximum 2 amps, and I'm guessing that's 2 amps shared between these two USB connectors because this is only a 3 amp buck regulator, so these wouldn't be able to do 2 amps each. What other components do we have on here? There's a little device there with a funny number on it. That's a MOSFET because it's connected to the negative side of this surface mount LED, and so that will be the drain. When that MOSFET is turned on, then the MOSFET will ground this negative side. So the microcontroller has control over the LED. It also has control over this LED. That probably runs directly into one of the microcontroller pins. We got some current sense resistors here, so this thing can detect whether or not current is being drawn by the USBs, and presumably if it's not for any length of time, it will shut off the output. Now this is the positive terminal of the battery. That seems to go through this diode, then through these 101 resistors, and then into this regulator. So I presume this is just for low current 5 volts. That might be for the microcontroller, so that it gets a nice clean 5-volt supply and not this big high current noisy one, potentially noisy anyway. There are a couple of fairly high power resistors here, look like low value. I've got a feeling they're just the current limiting resistors for the LED, because they're very close to, well, it looks like positive comes along this track here through these two resistors in parallel for a bit of heat spreading into the positive of the LED, and then the negative goes back through this MOSFET. So yeah, I think this LED doesn't have a particular LED driver on it, just has a couple of resistors. That's about it really. Let's get some close-ups now. So there's the AP2962 buck regulator, and there is the HT, now what is that, 66F004, I believe that is, and it's upside down, but you can probably just make out that that is a 7550-1, the linear regulator just to the right of center there. Of course, it's just occurred to me the other reason for having this linear regulator here is that this chip has a fairly low quiescent current, keeps the microcontroller switched on so that it can detect a button press, and then under control of the microcontroller is this buck regulator. So if there's no draw on the USBs, the microcontroller can shut down this buck regulator so that the current draw of the whole board is relatively small and therefore doesn't drain the energy in your power tool battery. And yes, this buck regulator chip does have an enable input. It's pin 7, and it runs back to this via, which then runs down around here, and that's where the microcontroller is. So the microcontroller is definitely switching on and off this main buck regulator. Now between the D plus and D minus pins on these two USBs, there is a single resistor, and it's marked 01B. And so if I look that up on kiloohm.info, I can see that the 01B is a 1K. Now, I was under the impression that you could short these two pins so that the device connected would say, oh, that's an unlimited power supply port. I can pretty much pull what I want. So does 1K across those pins mean something different? Not read anything about that. So that's a fun gadget. I think I paid about £10 for that on eBay. It was probably more like £5 or £6 in Lidl when it was available, but I've not seen it since. And actually, I bought this on eBay probably a year ago now, and I've been sitting on it. Right, let's see if we can get this back together. That appears to slide into a little slide there. LED somehow fits in there, not entirely sure how. Oh, there's a little plastic cover for that. I'd better get that on as well. And while this is sliding in, I've got to try and get this spring button on top of the click switch. And because that clips on that side, I've put the light pipe in there. Let's hope it stays there when I put this other side on. Oh, I don't really know how to do this. No, it's not going to stay there because it's fouling that capacitor, so I'm going to have to put it on that side. Maybe I'll move this belt clip. And now this should slide in here. But will it? Oh yes, it does. Just press that button a little bit and she's back together. And I just wanted to check the overcurrent protection of these USBs. So I've plugged in this load and that's pulling 1.5 amps and all seems to be well. Let's turn that up and see if it can manage 2 amps, which is the maximum this said it could do. So there's 2 amps, 1.999, that seems to be okay. Let's take it a bit higher. And it's cut out. So yeah, it does seem that it has 2 amp overload cutout protection on the USBs. Excellent. And interestingly, if I'm putting 1.9 amps and I turn the light on, that's enough to kill it. So it must be including the LED current in its measurement of total current that the buck converter is allowed to run at. Interesting. Cheerio.